Welcome to chapter 1, sequences and series, and we are on our third lesson for this chapter. And our lesson 3 talks about arithmetic sequence. So when we say arithmetic sequence, let's try to consider the sequence 6, 13, 20, 27 up to end. So we notice that from 6 to 13, we add 7. So the rule is add 7 to the previous term to get the next term. So when a sequence looks like this, where in which we add a constant value to the previous term. So as you can see, we add 7, we add 7, then we add 7. This all sequences that looks like this, in which we add constant values, these sequences are called arithmetic sequences. So by definition, we have an arithmetic sequence is a sequence which progresses by adding constant value to the previous term. So we may be confused by the word adding, but we can also say subtracting. But when you say subtracting by 3, we can say that it's also adding negative 3. So that constant value that we're adding, in this case, in this sample sequence, we have 7. So that 7 is known as common difference. In symbol, we write that as D. So in the sequence above, D is actually equals to 7. So for example, let's determine if each sequence below is either an arithmetic sequence or not. Okay? If the sequence is arithmetic, let's try to determine the common difference or the value of D. So number 1, we have 4, 9, 14, 19, and so on. This is an example of an arithmetic sequence because the sequence progresses constantly by adding 5. So D is equals to 5. Number 2, 7, 10, 15, 17, and so on. So this sequence is not an arithmetic sequence because from 7 plus 3, that makes 10, up to 15, that's plus 5, then goes to 17, that's plus 2. So the addition of the value is not constant. So this is not an arithmetic sequence. Number 3, we have 2, 4, 8, 16. So it seems like the rule is multiply 2 to the previous term to get the next term. So this is not an arithmetic sequence. Number 4, we have 50, 40, 30, and 20. This is an example of arithmetic sequence, though it's descending. So this one, we have a negative value of D. So in this case, our D is negative 10. Okay. The number 5, we have 1 half. It becomes 1. It becomes 1 and 1 half, or 3 over 2. It becomes 2. So yes, this is an arithmetic sequence. And the value that is added to the previous term constantly is 1 half. So that D is equals to 1 half. Then, in arithmetic sequence, of course, there is what we call the general term, meaning we have the formula for this arithmetic sequence, and that formula is given by a sub n, or any desired term, a sub n, equals to the first term, or a sub 1, plus n minus 1 times the common difference na D. So a sub 1 is the first term, n is the position of the desired term. Suppose we're trying to say find the 30th term, so 30 is our value of n, and D is the common difference, as what we discussed in the previous slides. So let us say here, find the 20th term of the sequence 5, 8, 11, 14, 17, and so on. So a sub n is equals to a sub 1 plus n minus 1 times D. That is our formula or general term of an arithmetic sequence. So let's try to find the values needed. So you have our n is 20 because we are trying to look for the 20th term. Our a sub 1 is 5 because our first term is 5. And our D is, since we know that this is an arithmetic sequence, so we just simply subtract any two terms. Okay, so second term minus first term, or you can also do it as third term minus second term. So in this case, what we did is 8 minus 5, the second term minus the first term, equals 3. So D is equals to 3. Then let us substitute these values to our general term. So we'll have a sub 20 or our 20th term is equals to the 5 plus quantity times plus quantity 20 minus 1 times the common difference 3. So we have 5 plus 19 times 3, and 19 times 3 gives us 57. 57 and 5 gives us 62. This means that our 20th term is 62. So if we're going to continue the sequence, the 20th term will be 62. So find the 51st term of the sequence 11, 15, 19, 23. So this is an arithmetic sequence. So let's try to find the needed values so that we can find the 51st term. We have our n is 51 because we are looking for the 51st term. Our first term, a sub 1, is 11. And our d is, we just subtract 15 minus 11 equals 4. And let us substitute this to the general term. We will have 11. A sub 51, or the 51st term, equals 11 plus 51 minus 1 times 4. So that's 51 minus 1. We have 50 times 4. We have 200. 200 plus 11, we have 211. Okay. So therefore, if we're going to continue the sequence, the 51st term will be 211. So find the 30th term of the sequence 188, 185, 182, 179. So be careful because this is a descending arithmetic sequence. Okay. So if the arithmetic sequence gets this is descending, it gives us the idea that the value of d is negative. But it depends because some fractions work differently. So our needed values are n equals 30 because we are looking for 30th term. Our first term is 188. Then we will subtract the first and the second term, 185 minus 183. That gives us our value of the common difference is negative 3. Then let's input that in our general term. So our a sub 30, our 30th term, is 188 plus 30 minus 1 times negative 3. So 30 minus 1 is 29 times negative 3, that's 29 times negative 3, that's negative 87. Then subtract from 188, that is our 30th term is 101. That is all for arithmetic sequence, how to find a specific desired term in an arithmetic sequence. So let us have the arithmetic means. So when we say arithmetic means are simply the keyword for arithmetic means are simply the middle terms of any given two terms. Okay, the middle terms of any given two terms in an arithmetic sequence. Okay, so suppose we have a sub 1, our first term, then we have a sub n, which is any term. Okay, any term. So, and these are the terms of an arithmetic sequence. Any terms between a sub 1 and a sub n are called arithmetic means. Okay. So consider the sequence 5, 7, 9, 11. So let's consider 5 and 11. Okay. So we say that 7 and 9 are said to be the arithmetic means of 5 and 11 because 7 and 9 are the middle terms of 5 and 11. Okay. So that is just the concept of arithmetic means. So let us try to insert one arithmetic mean between 9 and 17. Okay, 9 and 17. So 1. Since we are trying to insert one arithmetic mean, it's just like we are looking for a number that is midway between 9 and 17. Midway between 9 and 17. So in this case, we find the middle number between 9 and 17, or the midway. So since we are just looking for one arithmetic mean, it's like an average. Okay, if you know how to compute an average, just add the two values divided by 2. So 9 plus 17 is 26 divided by 2. The midway number between 9 and 17 is 13. So notice that after you get the arithmetic mean and you insert it between, you'll have 9, 13, and 17. And that's always 9, 13, 17 will form an arithmetic sequence. Okay, so 9, 13 plus 4, 13 plus 4, 17. So notice, okay? So when you insert an arithmetic, when you search some certain numbers of arithmetic means in the certain number of arithmetic means in the um, two terms, the resulting sequence will form an arithmetic sequence. If not, that makes the arithmetic means. So let us say here, insert two arithmetic means between 7 and 34. So 7 and 34, our first term, let us assume that 7 is our first term, if and 34 is the last term and under consideration. If you're going to insert two terms between that, that gives us 34 will become the fourth term. Okay, so 7 will become the a sub 1, the two arithmetic means will become the a sub 2 and a sub 3, and 34 will become the fourth term or the a sub 4. So we find first the value of d, because we know that if we know the value of d, we just simply add it to 7 or subtract it from 7 if it's negative. Okay, then if we can find the d, we can find the second term, which is, and the third term, which are actually our arithmetic means. So the, remember that 34 becomes our fourth term. So here, look at this. If we know the d, the value of d, we'll just add it to 7. We'll get a sub 2. Add it again 7. Add again that value of d, will get a sub 3. So in this case, we have a sub 4, which is 34, which is our last term under consideration for this one. So a sub 4 is 34. That makes us n equals 4 for 34. So n is always related to the 34 or to the term under consideration, which is in this case 34. So n equals 4, then of course a sub 1 will become 7. Then we substitute this in the general term of our arithmetic sequence. So in that, we're trying to look for d. So we have here a sub 4, 34, n equals 4, and a sub 1 equals 7. So we'll just substitute it here. Okay. So a sub n will become 34. So let us first substitute n equals 4 so that it will be clear for us. Okay. So a sub 4 now is, let's replace this with 34. So that gives us 34 equals 7, which is our a sub 1, plus 4, 1 minus d, will give us 7 plus 3d equals 34. And 34 and 7, that gives us 27. So 27 equals 3d. So 3d is, they share 27. Each d will give us 9. That gives us our common difference. So if we know the common difference, what is the purpose? We will add this to the first term. So we will get the second term. Here we have 7, a sub 2, a sub 3, and 34. We know that the value of d is 9. So we will just add 9 to that 7. So that becomes 7, 16, 25, and 34. So we have now our arithmetic means between 7 and 34, and those are 16 and 25. So let's insert two arithmetic means between 18 and negative 3. So let us say this 18 to negative 3, and we're going to insert two arithmetic means. That gives us negative 3, our fourth term. So it means that from 18 it becomes negative 3. This sequence, the resulting sequence after inserting two arithmetic means, is descending from higher to lower. So solution, let's find the value of d. The same procedure, okay? So our a sub 4 will become negative 3, and n equals 4, then a sub 1 equals 18. Then let's substitute that here in our general. Let's find the d. Okay, so a sub 4 will become negative 3. So we have there negative 3. Our first term is 18, then do the operation. 18, 4 minus 1 is 3d. That gives us negative 3 and 18, that gives us negative 21. And that is equals to 3d. D gives us negative 7. Meaning, from 18, we will subtract 7 or add negative 7. So if you're going to add, subtract 7 from 18, that becomes 11. And subtract 7 from 11, that becomes 4. And subtract 7 from 4, that becomes negative 3, which is correct. So here is the hint. So 18, 11, 4, and negative 3, it form an arithmetic sequence. When the resulting sequence is not an arithmetic, therefore, our arithmetic means are wrong. And that is maybe because our value of D is also wrong. So you have to take note of that. The two arithmetic means between 18 and negative 3 are 11 and 4. So let us try to insert. What if we're going to insert 4 arithmetic means between 11 and 41? Okay, so it's quite many. Okay, it's quite many. So imagine you have 11 and 41 and you're going to insert 4 in between, 4 terms in between. That gives our 41 our sixth term, remember. Okay, we insert 4 in between, then there are already 2, 11, 41. That makes 41 our sixth term. Why is it important? Because that 6 will become our value of n. Okay, okay, so our a sub 6 will become 41, and that is resulting to n equals 6, and a sub 1 is 11. Okay, then let's the same with the idea a while ago. We'll substitute it to in our general term for arithmetic sequence. So we have there, okay, a sub 6 is just equals to a sub 1 plus 6 minus 1d. Okay, and that becomes our a sub 6 is 41. So 41 equals 11 plus 5d, then 41 and 11, that gives us 30. 30 is shared by 5 d's. Okay, each d is 6. Okay, so meaning from 11, okay, we will just add 6 so that we will get our a sub 2. We'll add 6 again to get a sub 3. We'll add 6 again to get a sub 4. We'll add 6 again to get a sub 5, and we'll add 6 again to get a sub 41. Okay, and that is 11 plus 6, 17, plus 6, 23, plus 6, 29, plus 6, 35, plus 6, 41. So here's the thing. In 35 plus 6, that confirms our sequence. It's like the last addition of 6 here. That confirms that our work is correct. Why? Look at this. If 35 plus 6 is not 41, that makes our arithmetic means wrong. And maybe that is because our value of D is also wrong. So if 35 plus 6 is beyond 41, that's wrong. If 35 plus 6 is less than 41, that's wrong. It should be 35 plus our D should result to our last given term. Okay, because 41 is already established in the problem. Okay, so that's all for arithmetic means. Okay, so today we learned that we can find any term in an arithmetic sequence by using the general term of an arithmetic sequence. Number 2, we learned how to insert arithmetic means between any two given term in an arithmetic sequence. Okay. Few things to be careful. Few things to look at is that when we insert arithmetic means between two terms of an arithmetic sequence, the resulting sequence will also form an arithmetic sequence.